Hey guys, Mr. Ray here. We're going to continue on with our linear systems unit. This will be the second of 3 lessons. The previous lesson, it was lesson 1 that we did, but the lesson note was lesson 2, was learning an algebraic method called substitution to solve a linear system. So if you remember, linear system is basically 2 equations with 2 variables. Okay, so it could be as simple as x plus 1 equals 5 and say 2x minus 3y equals 12. I just made that up. So there's a linear system. Now, what does it mean to solve a linear system? It means find the values of x and y that make both of these true. Okay, so now I talked at the beginning of the last lesson that there's actual graphing solution you could do where you would graph these 2 lines. I'm really not sure where these guys go, but I'll just make something up. So where these 2 lines meet, the x value is here and the y value is here. That would be the solution. And graphically you could think of, well, the point of intersection is where these 2 lines meet. The more interesting way of thinking about it is I have 2 different unknowns here, x and y. I have 2 different sets of conditions on x and y. What are the values of x and y that will make this true? And like we talked about last lesson, you're not going to have a case where like there's 2 or 3 values for each that'll work. It'll either be nothing works or there is one x-y combination that works. Okay, so the one thing I want to talk about before today's lesson is when we did substitution, I could basically take this equation here and I could rearrange it. So I might have rearranged that to x equals 5 minus y. Okay, call that a different number, but these 2 equations were the same line if we graphed them. It's the same relationship, just rearranged. Okay, and that's how we were able to rearrange to isolate for x and then substitute this back into the second equation. Okay, but I can do more with this equation. Instead of just rearranging it, and I'm showing you this for today's lesson, I could actually take that equation and instead of just changing around the sides, moving things around, I could actually take that equation and say multiply it by 5. So what does that mean when you multiply an equation by 5? It means I multiply this by 5, I multiply this by 5, I multiply this by 5. So when I do that, I have a new equation where everything is 5 times bigger than before. 5x plus 5y equals 25. Okay, so there's a new equation, call it 4, but in terms of solutions, in terms of what this would look like if I graphed it, it's exactly the same as this equation and this equation. Okay, so that's something we're going to be doing today. We're going to take an equation and we're going to be multiplying it in order to use the technique. Okay. So the second technique, algebraic, and you'll see that this is probably the best technique. It actually, the really good thing about this technique is you don't have any fractions unless you actually have one of your variables. Once you determine that that variable is a fraction, that's the first time you'll see the fraction. Okay, whereas with substitution, you might have had lots of fractions along the way. Okay, so this will get rid of that issue. So this method is called elimination, and let's see what it means. Solve a linear system by adding or subtracting to eliminate one of the variables. So in most cases, if you had x's and y's, you're actually going to be doing something to get rid of the x or get rid of the y. And we kind of eliminated that using substitution, but this is a different technique entirely. Okay? All right. Now, there's a series of steps here for the process. I'm not going to talk about that yet, except for we need to align set these up so that the equations are lined up correctly. Okay, so what do I mean by that? So let's go right to the example here. So it says solve the system of linear equations. I've got this equation, I'll call it 1, and this is 2. And what I mean by arranging it so that they're aligned, it's kind of like when you, back in elementary school, when you added numbers, you had to make sure the hundreds was lined up, and the tens and the ones and the tenths. So in this case, you have your x terms above each other, you have your y terms above each other, equal signs, and then the constant. So I would say in probably 90% of the cases, it will always, the linear system will be given to you this way, but there will be a couple of questions where you need to rearrange it so that they are lined up in this way. Okay. Now, we're only going to be doing 3 examples in today's lesson. Each of them represent a different case. So we're going to start off with the best case. If everything was, everything was aligned correctly, this is the example where we have to do a minimal amount of work. And then the next example will be the medium case, where it's a little bit more work to solve it. And then the third is the maximum case. But in reality, the maximum's not that bad. Okay, so let's jump right into it. Okay, so I'm going to rewrite these equations down here. Again, keeping them aligned. 3x plus y equals 19. And 4x minus y is equal to 2. Okay, now the very first thing we do is we're going to try to eliminate either the x's or y's by adding or subtracting the equations with each other. So the first thing I'm going to say is, if I add these 2 equations, or if I subtract these equations, can I get rid of one of the variables? And you can see when I have a 3 and a 4 here, by adding or subtracting, if I added these two together, I get 7x. That's not getting rid of it. If I subtract it, I'll have 1x or negative 1x. So that's not going to get rid of it. But this, with the y, I have a plus y and a minus y. You can hopefully easily see that if you add these 2 equations together, the y's actually cancel each other out. They add to 0y. Okay? So that's the very first thing we check. This is the best scenario. See if you can, without doing anything, can we just add or subtract these equations with each other and get rid of one of the variables? And in this case, you can. So you have to be very clear what you're doing. So I'm going to add these 2 equations together. So I want to make sure that your communication skills are good here. Tell me what you're doing. You're adding equation 1 plus equation 2 on this step here. So this is where we add vertically. So 3x plus 4x is 7x. Plus y plus negative y, that's 0y. If it gets rid of the variable, just leave it blank. Okay, 0y is the same thing as nothing. So, and then I put my equals, and then I add these 2 together. 19 plus 2 is 21. Okay, and you can see it got rid of the y. Now to get x by itself, just divide both sides by 7, and I have x equals 3. And it wasn't that easy, okay? You can see the best case scenario, this technique is a lot faster than substitution. We just add the equations together. And some of the questions we had in the last lesson, you could probably go back to those and go, oh, it would have been so much easier just to use this elimination technique rather than do substitution. And you'd be right. Okay, now the rest of this is exactly the same as what we would have done with substitution. Okay, we take that solution for x and we substitute it back in. So substitute x equals 3 into, and here's, you get to choose your equation. Now we don't have an equation say y equals anymore. It has to be one of these 2. Obviously, it can't be that equation because there's no y anymore. So you basically choose 1 or 2. I'm going to pick 1 just because everything looks positive there. So I've got 3, and I got my x there, plus y equals 19. That was equation 1. And now where the x was, I change it to a 3. I've got 9 plus y equals 19. And then subtract 9 from both sides, I get y equals 10. Okay, and therefore the POI is, and the point, x coordinate first, 3, 10, and there's your answer. Now, again, you could do a check for this. Actually, it tells us we have to, so let's do that. So the check, again, make it very clear that below this line is the check, above it was where you were making your solving steps, okay? So we're going to check the point that we think it is, 310, and I'm going to plug it into both equations. 3x plus y equals 19, and 4x minus y equals 2. So x is 3, y is 10. So that's 9 plus 10 is 19, and add them together, 19 equals 19. That is correct. So what does this tell us? This tells us that that point, 310, is on the first line. Okay? It hasn't proven yet that it's the point of intersection. We actually have to prove it's on both lines before we can state that. So now I'm going to plug the point 310 into here. So 4 times 3 minus 10 is equal to 2. 12 minus 10 is 2 equals 2. Yes, that point is also on the second equation. So that means the point is on both lines. So it has to be the point of intersection. Okay. So like I said on the first lesson, it really pays to do this. Even if you do it in your head, plug these back into these equations, see if it works. You know it's right. You don't have to hope. Okay, so that's the best case scenario. We're able to add or subtract right away and to eliminate one variable. Okay, so this will be the medium case, medium difficulty. Okay, so there's my two equations. So I'm going to write them over here. 10x plus 4y equals -1. 8x minus 2y equals 7. Number the equations. This is really important in this process, and you're going to see why. Make sure my x's look like x's. Okay, so we start off by trying to do what we did in example 1. Can I add or subtract these equations to get rid of the x or the y? And you can tell, well, the 10 and the 8, I would get 18 if I added. I get 2 or -2 if I subtracted. Same issue here, it's never going to get rid of them, okay? And you can always tell if the easy case will work because the numbers in front will be the same number but possibly a different sign, okay? So you could just look at this and go, okay, I have to, it's not the easy case, okay? So what do you do if that doesn't work? Well, you then ask yourself, can I multiply one of the equations, like I showed you at the beginning, take one of these equations and multiply it so that then I can add or subtract the equations and get rid of the x or the y. So what we're looking at is, again, we're looking at the 10 and the 8 and the 4 and the -2. So if I multiplied, and let's pick the lower one, if I multiply the 8 by a number, and it has to be an integer, can I ever get to a 10? No. Right? If I multiply that by 2, I get 16. It's not going to get rid of the x, right? But if I look at this, I've got a 2 or -2 and a 4. If I multiply this by a 2, that would turn it into a -4, and then I could add these two together and get rid of the y's. Okay? So you're looking at, is one of the coefficients a multiple of the other one? And if that's the case, this is the medium level difficulty. So let's do that. And I want to show you the technique Again, communication is king here. You have to tell me what you're doing rather than just write a bunch of random steps and I have no idea what you're doing. So what do we want to do? We want to take this equation, equation 2, and multiply it by 2. So I'm going to put it right here, equation 2 times 2. So now I'm going to double all three of these numbers. I get 16x minus 4y equals 14. And that's a new equation 3, but it's really the same as equation 2. These are the same lines. Just the equations look different, okay? Now, some people don't do this. I think it's a good thing to do. I'm just going to copy equation 1 down here. So 10x plus 4y equals -1. That's equation 1 again. Okay? And I like to do that because now I can, the numbers are on top of each other here. I can actually compare them a little easier. So what do I need to do to get rid of the x or y? Well, we've already decided we're going to get rid of the y's by what we did in the previous step. When I add these together, it will get rid of the y's. So you have to be careful. Some people will say that you have to subtract here. No, if the signs are opposite signs, one positive, one negative, but the same number, you always add them together. If the signs are the same, if this was plus 4y, you'd subtract. If it was -4y, you'd subtract. So in this case, we're gonna add these two equations together. So I'm going to state that right here, equation 3 plus equation 1. Okay, so now we're going to add 16x plus 10x, that's 26x. -4y plus 4y, that's gone, nothing. And if I add these two together, I get 13. Now divide by 26, and we get x equals 1/2, or 0.5. Okay, and I can do the 0.5 because it's exactly the same thing. I'm not rounding. What you can't do is if it was x was 1/3, I don't want you writing it as 0.3 or 0.33. Okay, if you're rounding, you're not doing it because we're dealing with exact numbers all the time. We do linear systems. So now we take that so that the elimination step is done. We just do what we'd normally do. Substitute x equals 0.5. Now again, here's your choice. You can plug it into equation 1 or 2. Okay, I'm going to pick the second one. No real great reason. Maybe because the 8's smaller than the 2. Not sure. But it would work equally well if you plugged it into 1. You just have to decide. So that's going to be 8x minus 2y equals 7, and the x is 0.5. So 8 times 0.5 is 4 minus 2y equals 7. Subtract 4 from both sides, get 3, and divide by -2. Y is equal to -3/2 or -1.5. Okay, and then you can make the statement. Always conclude with a POI statement, or the solution is statement. So therefore the POI is x goes first, so 0.5, y goes second, and there's the point of intersection. If you wanted to, you could check it out, plug these values in, see if the left side equals right side. Okay, but they will. I've checked it previously. Okay, here's the third example. So this will be the worst case scenario. It's not that bad, but it's not quite as easy as the first two examples. Where do these lines intersect? Verify your answer. So again, I'm going to line these up, one above the other. 4x plus 3y equals 13. Equation 1, 5x minus 4y equals -7. Equation 2. Okay, so let's pretend we don't know this is the worst case. Let's discover it for ourselves. So can I add or subtract these equations with each other and get rid of x's, or the x or the y? Well, the fact that these coefficients are different numbers Okay, it means we can't. Okay, so we're on to the second case. So I look at this case, the 4 and the 5. Can I multiply the 4 by something that would give me 5? And that something has to be an integer? No, because 4 times 2 would be 8. I'm not going to get rid of them that way. Can I multiply, and usually start with the lower number in terms of the actual number part. So can I multiply 3 by an integer to get 4? No. Okay, so I can't do what we just did in example 2. So here's the case, and this will always work. There's not a fourth type of strategy. You basically say, okay, I'm going to choose right now which variable I'm going to get rid of. And for me, I would usually pick the lower number, the smaller looking numbers. So I'm going to pick the 3 and the 4 instead of the 4 or 5, but you know, I'll explain how you could do it, eliminate the x's just as easily. Okay, so what we're going to do, we're actually going to multiply both equations by different numbers. So I'm going to multiply equation 1 by 4 because that's what the second equation has here. So I'm going to multiply this equation by 4, this equation, second equation by 3. So when I multiply this by 4, I get a 12y. When I multiply this by 3, I get negative 12y. And then I can add or subtract them together. So the only difference between the second and third example, you actually multiply both equations by some different number. Okay, so I'm going to say equation 1, multiplying that by 4. So when I do that, multiply each of these by 4, I get 16x plus 12y equals 52. That's equation 3, which came from 1, obviously. And then equation 2, I already said I'm going to multiply that by 3 to make them the same number here. So equation 2 multiplied by 3, don't forget, everything gets multiplied by 3, all the numbers. 15x minus 12y equals negative 21. That's equation 4, and it came from equation 2. All right. So we basically converted both of the original equations into a new version. But like I said at the beginning, if I was to graph equation 1 and 3, it'd be the same line. If I was to graph equation 2 and 4, it'd be the same line. So by multiplying an equation by the whole equation by a number, not changing what the solution is or what it looks like. Okay, so now we've already decided, we've set this up so that we can eliminate the y. So you have to decide, are we adding or subtracting these two equations? And again, same situation as before. If the signs are different, you have a plus and a minus, you want to add the equations together. Okay, so we're going to do equation 3 plus equation 4. Okay, now if these signs were the same, if that was plus 12y, we would subtract. If it was negative minus 12y, you'd subtract. But when they're opposite, when they're different signs, you always add. So when I add these two, I get 31x. When I add these two, obviously, the whole reason we did it, it eliminates the y. And when I add these two, I get a 31. And that worked out nice because that means x is 1. Okay, so done the elimination step. Now we just do the regular substitution step like we've done every single example. Substitute x equals 1 into, and we choose one of the original equations. I'm going to pick equation 1 just because the numbers are smaller. So I have 4x plus 3y equals 13. And x is 1, so it goes where x was. So that's 4 plus 3y equals 13. And then I'm going to subtract 4 from both sides. 3y equals 9. Divide both sides by 3. Get y equals 3. So, therefore, the POI is the point 1, 3, 1, 3. And you could very easily just check this out. Plug in a 1, 3 there. I get 12. So I get 4 plus 9 is 13. That works. Here I would get 5 minus 12 is minus 7. So just by doing it in your head, you can know for certain that this answer is correct. Okay, so I've got some questions. This is just practice questions like you had on the last lesson. Make sure you can do this. Now, I've already said that this is probably your preferred method. You have to practice it a few times, but I think most of you will at the end say, I like this method, I want to do it all the time. Okay, that's fine. When we do word problems, which will be the last lesson of the course, which will be next week, you can use whichever the methods you want. Okay, but on the assignment, you're actually going to have to know how to use both methods. I'm going to ask a question, solve this linear system using substitution, and then solve this linear system using elimination. And then when I get to the word problems, I don't specify the technique to use. It's up to you. Okay? So one more lesson to go. It's going to be a pretty interesting lesson. This will be a longer lesson too. It's basically solving word problems by creating a linear system out of it first. We saw that in the last lesson where we did the fish problem, where the two people had a different number of fish, and we created a linear system and solved it pretty quick. So there's going to be some other kind of cool questions that we're going to look at, and then the course is finished. Okay, so there won't be an assignment for this coming weekend. There will be a lesson on Monday, and then probably going to be releasing the assignment Tuesday, Wednesday, just to have a chance for a bonus if you get it in that day. And then it'll be, I think, everything, the absolute due date will be the following Sunday at midnight, which is normal. Okay, so hopefully that made sense. If it doesn't, come join me on my office hours. Thanks, guys.